This whole thing happens when we press the standby button, that is, electrons are ready from the cathode end. When exposure button is pressed, high voltage is given across the cathode and anode. Hello everyone, let's continue the topic that we have covered in our previous video. The topic is X-ray generator circuit. This X-ray generator circuit composed of main voltage compensation circuit, KV circuit and MA circuit. A small note here, some authors have described the circuit with different headings like primary and secondary circuit or high voltage and low voltage circuit, but please don't worry about the headings, the components are all same. First, let's see why the X-ray tube requires power. It requires power for two primary reasons. One, to boil off the electron from the filament, that is thermionic emission to occur. Second reason is to accelerate the electron from cathode to anode. Now let's discuss our first heading, main voltage compensation circuit. It starts from AC main electrical power, goes till the auto transformer through main voltage compensator. The compensator is made up of tappings which provides constant volts per turn, and there is a main voltage compensation meter which measures volts per turn, and it shows us the voltage is compensated or not. There we have a circuit breaker. Circuit breaker is same like the trip that we use in other equipments. If the voltage is not compensated, then the circuit breaker will automatically cut off the power that goes into the circuit. In modern day equipment, we use voltage stabilizers which gives stabilized voltage to the circuit. Our second heading is KV circuit. Before going into the circuit details, let's see some of the main components that are used here. First, auto transformer. Unlike traditional transformer which has two separate coils, auto transformer has only one single winding of coils that acts as both primary and secondary side. You can see here it has two coils, but here you have only one coil. Principle of auto transformer is self-induction. This is an example of step-up transformer. Here you can notice the number of turns in the secondary coil is higher than the primary coil. As per the laws of transformer, step-up transformer increases the voltage but decreases the current. This is the step-down transformer. Here the number of turns in primary is higher than the secondary coil, so it increases the current but decreases the voltage. Step up increases the voltage, step down decreases the voltage. This is the high voltage transformer. This high voltage transformer is a step-up transformer with voltage gain of at least 500. The voltage gain will be a single value, that is a fixed value per transformer. Here the turns ratio may vary depending on the machine. Typical turns ratio are 500:1 and 1000:1. Output from the high voltage transformer goes up to 150 kV and 1000 milliampere. The secondary of high tension transformer is centrally earthed to get equal positive and negative voltage across the ends. Next component is KV selector. KV selector selects the number of turns by adjusting the tappings. By adjusting this major and minor KVP knobs, we can select the decided KVP. Example, if 100 turns is selected, the voltage selected by KV selector is 100 into 2, that is 200 volts goes in. Next, pre-reading KVP meter. It measures the voltage selected by the KVP selector but indicates the expected kilovoltage applied across the X-ray tube. That is, it doesn't show the voltage flowing through it, but it shows the expected voltage that is going to be supplied on the X-ray tube. Expected KV is equal to voltage selected by the KV selector multiplied by voltage gain of the high voltage transformer, that is step-up transformer. If we have chosen a gain of 500, then 200 into 500 equal to 1 lakh volts, that is 100 kVp. Next, the switch or the timer. If exposure button is pressed, the switch will be closed and the timer starts functioning. Once the preset time is reached, the switch opens up and cut off the power supply to high tension transformer. Timer can be manual, electronic or AEC, that is automatic exposure control. Next is rectification process done by rectifiers. The secondary voltage from high tension transformer is rectified either through half wave, full wave or constant potential. Then it gets supplied to X-ray tube. This is the summary of KV circuit. Just pause the video and go through it. Now let's discuss MA circuit in detail. First, MA selector. It selects any one of the resistor having different resistance value. Here we have taken 300 mA machine as an example. Let's see what happens inside once you turn the MA selector knob. Let's say you have selected higher MA. Then the resistor with low resistance is selected. Since the resistance is very low, there will be a low potential drop, that is voltage loss is less. So the voltage given to the filament transformer is high, resulting in large voltage applied to the filament. So the filament will be heated to high temperature and it results in more electron emission. Here we have higher tube current, that is higher MA. If low MA is selected, that is resistor with high resistance is selected, here everything reverses, resulting in lower MA. Next to MA selector we have filament transformer. Filament transformer is a step down transformer with turns ratio approximately 20:1. It reduces the voltage and increases the current. This step down power goes into the filament. With this filament current, the filament starts heating and emits electron. This process is called as thermionic emission. Here I forgot to mention one thing, that is focal spot selector. Either small or large focal spot can be selected, by which we can decide which filament to be energized. This is the summary of MA circuit. Pause the video and go through it. Now let's describe the overall process with an illustration. Please read the summary first and come back here. Then only you can understand it properly. The AC mains is compensated so that we can get a stable input voltage. The compensated voltage is around 220 volts. Let's say we need 100 kV output from the X-ray tube. Through the KV selector, by adjusting the minor and major KVP tapping, we select the KVP. Let's take the voltage gain factor of high voltage transformer as 500. So the voltage needed from the auto transformer is 200 volts, that is 100 turns into 2. Here KVP meter shows the expected voltage, that is 100 kVp. After setting the technique, we press exposure button. Once switch is pressed, the circuit closes, that is circuit get connected and the timer starts functioning. Then electrical current goes into the high voltage transformer where it gets stepped up. Here the gain of step up transformer is 500, so 200 into 500, that is 100 kilovoltage. Then this alternating current is converted into direct current with the help of rectifier, which is then supplied into the X-ray tube. Now let's see what happens in the MA circuit. While setting the technique itself, we have selected the MA. Once we press the standby button, the power flows into the filament transformer through MA selector. Here the power is step down, that is voltage decreases but current increases. Let's say 220 volt flows into the filament transformer. Since its turns ratio is 20:1, the voltage will be reduced to 11 volts. This reduced voltage and increased current flows through the filament, resulting in filament heating and thermionic emission takes place. That is, electron will be emitted. The current that flows through filament is called as filament current, which will be approximately 4 to 8 amperes, and the voltage will be in the range of 8 to 12 volt. This whole thing happens when we press the standby button, that is, electrons are ready from the cathode end. When exposure button is pressed, high voltage is given across the cathode and anode. So the electron get accelerated from cathode end towards the anode end, where it get converted into X-rays. This flow of electron from cathode to anode is called as tube current, and this tube current will be indicated in the MA meter. This is what happens when we press standby and exposure button. Please go through the summary again. I hope you got some points. See you in next video. Thank you. Until then, signing off, Arun Yuvarajan.